Gear pairs design calculations. Draw the structure and speed diagram for 6-speed gearbox with minimum speed of 1000 rpm and maximum speed of 5000 rpm, along with kinematic layout for gearing of calculated 6 near speeds. We know that Nmax n upon Nmin equals to 5z minus 1. Phi is 6 minus 1, 5000 upon 1000, which is 5. So we have got speed ratio as 1.379. Now the 6 speeds are as follow. So we have got 1000 rpm first speed, 1380 rpm second speed, 1900 rpm third speed, 2620 rpm fourth speed, 3620 rpm fifth speed, and 5000 rpm as sixth speed. The 8 structural formula that we can conclude out of the structure formula layout, we have got 2132, 2231, 3221, 3122, 3123, 3321, 2331, 2133. So two rules for checking the formula are feasible or not are z greater than equals to pkxk and z by pkxk must not be integer, it should be a real number. So first formula 2132 is feasible. Second structure formula as per rule 2 is not feasible because 2 cross 2 is equals to 4, that is pkxk, the maximum value of pkxk, that is 2 cross 2 and the ratio of 6 by z by pkxk, that is 4, is 1.5, which is not a real number. So 3221 is feasible because it satisfies both the conditions. 3122 as per rule 2 is not feasible because 2 cross 2 is 4 and 6 by 4 z by pkxk is 1.5, which is not a real number. 3123 is feasible. 3321 as per rule 1 is not feasible because z equals to 6 whereas pkxk is equals to 9, 339, and 9 is greater than 6. So according to rule 1, it is not feasible. Also 2331 is feasible. 2133 is also not feasible because of rule 1, which is z is smaller than pkxk. Z should be greater than pkxk, but actually z is smaller than pkxk, that is 6 and pkxk is 9. So this formula is also not feasible. So overall we have got 4 structure formula that are feasible. So for acquiring appropriate structure formula, 2 steps acquiring for appropriate structure formula is transmission range, which is maximum transmission range in a stage divided by minimum transmission range should be less than equal to 8. And the second is node of method of optimization for acquiring the appropriate structure formula diagram. So first structure formula is 2132. It is 2 lines with a gap of 1 and 3 lines with a gap of 2. For stage 1 we have got the transmission range as 1.379, which is less than 8, so it satisfies it. Also for stage 2 3.616, which is less than 8, also this structure formula satisfies to be feasible. This is second structure diagram 3221. And the transmission range for first stage is 3.616, which is less than 8, and for second stage also the transmission range is 1.379, which is also less than 8. This is third structure formula. For first stage the transmission range is 1.901, which is less than 8. second stage transmission range is 2.622, which is less than 8. This is force structure formula, that is 2.622 transmission range, which is less than 8 for first stage. For second stage, the transmission range is 1.901, which is also less than 8. So this structure formula is also feasible. So this is the node matrix of optimization. So from the node starts from top to bottom and the speed starts from bottom to top. So after calculating the highest node, node numbering starts from 1 to 6 from top to bottom, and speed starts from n1 to n6 from bottom to top. So highest node number is calculated here. The overall sum node is 13.5, 15, 14 and 14.5. The structure formula which has the lowest number of sum of node is the optimum structure formula. So first formula 2132, which has the lowest number of formula, is the optimum structure formula. This is a speed diagram. So first speed diagram is 2132, that is 1000 RPM, 1380 RPM, 1900 RPM, 2620 RPM, 3620 RPM and 5000 RPM. This is the input speed, which is 2228.45 RPM, that is calculated as later shown. So for the speed diagram, the input speed is calculated as log ni equals to log n3 log 5 by 2, where log n3 is 1900 RPM, log n 1900, and phi is 1.379, which is log 1.379 by 2. So we have got 3.348 as a log ni. So ni equals to nt log of 3.348, which is 2228.45 RPM. Now we have calculated the gear ratios for different speeds. For first gear pair, we have got 1.175 gear ratio. For second gear pair, we have got 0.852 gear ratio. For third gear pair, we have got 1.908 as a gear ratio. For fourth gear pair, we have got 1 as a gear ratio. For fifth gear pair, we have got 0.526 as a gear ratio. Now after calculating the gear ratio, we have to calculate the number of teeth on each gear. So let A equals to T1i, B equals to T1o, C equals to T2i, D equals to T2o. There are 3 guidelines in here. For 20-degree full depth include gear pair, number of teeth on smallest gear should be greater than or equal to 18. Second guideline is in a stage gear pair, sum of number of teeth on a gear pair must be same. And the third guideline is minimum difference between the adjacent gears in a chain gear block must be equal to or greater than 4. So let we assume first of all B equals to 30, which is greater than 18. First guideline is met. A plus B equals to C plus D. Second guideline is also met. And third guideline, A minus B equals to 4, D minus B greater than or equal to 4 is also met. So after solving, we have got A equals to 35, B equals to 30, C equals to 30 and D equals to 35. So the new gear ratio is 1.16 and the second pair gear ratio is 0.857. Similarly, we have again assumed that TT3i equals to A, B equals to T5I, F equals to T5O. Let B equals to 20, A plus B equals to C plus D. Second guideline is also met. A minus C is greater than or equal to 4, D minus B is greater than 4. Third guideline is also met. So we have got A equals to 40, B equals to 20, C equals to 30, and D equals to 30. For second gear pair, we have got 40 and 20 as gear teeth. For fourth gear pair, we have got 30 and 30 as a teeth. Again, similarly, we do it for the last gear pair. After solving, we have got C equals to 30, D equals to 30, E equals to 20, and F equals to 40. Therefore, new gear ratio is 0.5, which is E by F, which is 20 by 40.5. These are the table for the new gear ratio. So new gear ratio is 1.16, and second gear pair gear ratio is 0.857, third gear pair gear ratio is 2, fourth gear pair ratio is 1, and fifth gear pair ratio is 0.5. So we have got input speed as 2220 with 0.45, multiplied by 1.16, we have got 2585 RPM by first gear pair with speed. On the second gear pair speed, we have got 19,907.1 RPM. So for both gear ratios, we have got 3 consecutive speeds. Overall 6 speeds we are getting for 6 speed gear ratio. So first speed is 954.89 RPM, second speed is 1292.5 RPM, third speed is 1909.78 RPM, fourth speed is 2585 RPM, fourth speed is 3819.5 RPM, and sixth speed is 5170 RPM. So after that, we have calculated the deviation of calculated speed. For first speed, we have got plus 4.7 as a deviation. Second speed, we have got 6.76 as a deviation. Third speed, we have got 5.512 as a deviation. Fourth, we have got 1.35 as a deviation. Fifth, we have got 5.22 as a deviation. And sixth, we have got 3.28 as a deviation. But allowable deviation is 3.79. Now, if we see our conclusion, then it says if we want to check the variation of highest calculated speed, that is 3.28, that is within tolerance. Highest calculated speed variation is within tolerance, although the lowest and some middle speed are not within variation tolerance. So we can conclude that if we want to design a gearbox in accordance to only highest speed, highest speed, that is 5170 RPM, and that is within tolerance of speed limit 954.70 RPM, the teeth are suitable for gearbox of 6 different speeds. But if we want to check that all the speed variations within limit tolerance, then we have to solve for new number of teeth and gear ratios for further analysis. This is the gear pairs layout. For first gear pair, we have got 35 teeth and 20 teeth. For second gear pair, we have got 30 and 35 teeth. For third gear pair, we have got 40 and 20 teeth. For fifth gear pair, we have got 30 and 30 teeth. Gear pair, we have got 30 and 30 teeth. For fifth gear pair, we have got 20 and 40 teeth. So this is a 6-speed gear pairs layout. Thank you for watching this video, and do subscribe to my channel Self Study Mechanical Techniques to Succeed, and press the bell icon.